So second lesson here, symmetry. We're going to talk about this a little bit. We want to know what are the three types of symmetry, how do we determine if something is symmetric algebraically, right? I think we have a lot of practice in the past of finding symmetry by looking at a graph, something we can determine pretty easily. But if we have a more complicated function, we want to be able to determine if it has some kind of symmetry without having to go through the effort of graphing it. And then why do we care about symmetry? How is it useful? And we'll do an example problem with that later on. Alright, so we have three types of symmetry. The one at the left here is an example of x-axis symmetry. The important thing to notice here is that for every x-axis, for every unique coordinate x, y, I must have a same x value. I must always be able to get out a negative coordinate of the y value, right? So if I have x is 3 possibly and y is 4, that means down here I must have x is 3 and y must be negative 4. So in order for this to actually have x-axis symmetry, both of these points must be true. They must both be solutions. So this is x-axis symmetry. And over here in the middle, similarly we have y-axis symmetry. This is y-axis. And if you look here, we have a very similar setup, but in this case our x values are the ones that reverse signs. So if I have negative 2, 6, on the opposite side I must have 2, 6. And this will be true for every value. So if I had a point down here at, let's say, negative 1, 2, I must also have the point 1, 2. So what we can see here is by determining one point on the graph, we can find a second point automatically once we know the type of symmetry we have. And this last one here we call origin symmetry. It's symmetric about the origin. In reality, it's really a combination of the first two. If I were to take this top piece here and I were to reflect it over the x-axis down here, I would end up with something like this. Alright, and if I was able to take that and then reflect it over the y-axis, it would then match this here. So now both values have the opposite sign. So if I started with 3, 5, I must also have the point negative 3, negative 5. Alright, and take a look here for an example problem. So you have to sketch a graph that has each of the following attributes: something that has x-axis symmetry, another one that has y-axis symmetry, and then something that is symmetric about the origin. Try to make something a little original, something different than what was in the example problems. And then as a bonus, which one of your graphs is not a function, right? One of those, A, B, or C is not a function, and the cool thing is everyone in class should have the same answer. It should be A, B, or C for all of us. So give that a shot, pause the video if you need to, or come back to it later on. Alright, move this down a little bit so you can see it. Alright, so if I want to find out if something is symmetrical without actually graphing it, I am going to follow these rules here. So the graph of an equation is symmetric with respect to the x-axis if replacing y with negative y. So these are important things. Y with negative y yields the same thing, right? And we saw that before when we had this type of symmetry. If I had x, y, I know that x, negative y should also be true. So when I substitute these in, I should end up with the same result. So I have this here, And I can check it easily, so I will replace y everywhere I have a y. I'll replace with a negative y. I'll have negative y, and put that in parentheses, that's important, squared. And if I simplify this a little bit, I see it's x minus, and this ends up still being a positive y squared, because negative y times negative y is positive y. And if we look, this here, and the equation we started with are the same. So this must have x-axis symmetry. Alright, so it's x-axis symmetry. We can try something here. If we want to try to find y-axis symmetry, we replace x with negative x. So I'll do it over here. Instead of having x, I'll put a negative x everywhere. So I go here, negative x minus y squared equals 0. Fortunately, this is not squared here, so I look and I see that this and this, our original, are not the same anymore, so it cannot have y-axis symmetry. It's not a possibility. And then we want to check, see if it has symmetry about the origin, so we're going to replace both values, right? We're going to make it a negative y and we're going to make it a negative x. So I will go here, I'll have negative x minus a negative y squared equals 0. I have negative x minus y squared equals 0. We still have the same issue we had before, and these negative x's do not match with the original function, so it also does not have symmetry about the origin. Alright, let's do one more quick example and then we'll move on here. Alright. So, same thing here, same rules apply, they always do. If I want to check for x-axis symmetry, I'm switching the y values. So I have negative y equals 1 over x squared plus 1. You can tell right off the bat here that this is not going to work because of this negative value here. So x-axis symmetry is a no-go. Moving on to y-axis symmetry, check with negative x, and we can see here it's kind of giveaway with this squared value with the quadratic that we are going to have something that works. So we have y equals 1 over, now we have negative x quantity squared plus 1, and that simplifies to exactly what we started with, 1 over x squared plus 1. So we have y-axis symmetry, and last but not least, we switch both values, and just like before, we're going to run into the same issue we had right here, where I'm going to have this negative y, so we know we're not going to have symmetry about the origin. Alright, we're going to do the same thing for your practice problem here. Identify any intercepts, so this should be a review here, so check the intercepts and test for symmetry. Do all 3 tests, see what we have. And then once you have this information, sketch a graph. If you need to, the easiest thing to do would be to make a quick table. If you make the positive or negative values and you know it's symmetrical, you can easily flip it to get the other points. Just make a sketch. Alright, try to use the information you already have without doing any more work to sketch the graph. And that's it. And